I'm live. Hey, I'm live. Am I live? Okay. He always say 9:41. I don't know why. There is a from I actually talk about why it's always 9:41. Um, I'm streaming right now. Huh? I can stream on Twitch on school properties. Yeah, but I did stream it last year when I was trying to do AP preparations. I did stream on Twitch at home. And I was the only person streaming calculus on Twitch. And nobody watched me apparently. So there was a category for that. Really? Yeah, people streaming chats. People streaming math. There's no difference. Okay, so let's talk about limits, and we'll talk about infinite limits. So we're gonna say limit when x approach infinity. So let's start with something that's relative different from before. Before we did one-side limit. So limit as x approach 2 from the left side of 1 over x minus 2. Do you guys remember what is this?
Infinity? Sorry, negative infinity.
Is going to be negative?
Yeah, negative infinity.
Negative infinity, good. Because if you plug in 2 first, so it's going to be 1 over 2 minus 2, that's equal to 1 over 0. That result two things, positive infinity or negative infinity. So now we're going to plug in 1.9 minus 2. So that's equal to positive over negative, and that's equal to negative infinity. So that is one-side limit. But what we're doing today is not one-side limit. What we're doing today is limit x approach infinity. So limit x approach infinity. As x approach infinity. Okay, so the idea is to ask students to understand what happens when limit x approaches infinity. So that is kind of difficult for people. So let's start with the limits. X approach infinity. And we're going to say, what if I have some type of number, we're going to call it c over x to the r is equal to 0. And the limit x approach to negative infinity of c of x to the r is equal to 0. So that's very, very confusing, right? C, what is c? C could be any constant. C could be 9 billions, could be 9 trillions. It doesn't matter. It's a number can be defined as a number. Okay, so let's just say a number over x. So that would be a better way to explain it. That's the way I would explain it. X approach infinity of a number over x. It didn't care about what a number is. Or x to the which power. As long as it's greater than 1, then it's fine. Then it's always going towards 0. Does that make sense? Do you guys understand why it's going to 0? Just think about it as 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 1,000, 1 over 10,000, 1 over 100,000, 1 over 1 trillion. It's going towards 0. But it didn't matter what the numerator number is. It could be 9 trillion. I can have 9 trillion over 10 gazillion. I don't know if that's a number. Then it's still going to be relatively going to small number, right? So the bottom is going to infinite. It's like a universe, keep on expanding. There's no define. Infinite is like keep on going. It's not stopping. So if you have some numbers defined on the top and there's some numbers not able to define as extraordinary big, it's not definable, then therefore it's always going to 0. Yes? Robert?
That's starting to make more sense. I was confused because I was like, what was the situation like? Okay, well if your number's like 100 and then like x is 1, then like.
But x is going to infinite.
Right, because x can go anywhere.
Yeah, it just keep on expanding. So let's think about amount of sand that you can put in this room, right? Let's say probably 5 billion pieces of sand, right? But compare how much is sand in the world, this is insignificant. This is just one room of sand, right? Even though there's a lot of pieces of sand in this room, it's still not comparable to the world. And we're not even compared to the universe. We're just compared to maybe Florida. Then this has become insignificant. So eventually it's going to go towards 0 as a comparison. It didn't matter if I approach from the negative infinity, it's still number over 0, it's still going to equal to 0, regardless of what happened.
Because
Okay.
X like gets bigger and approaches 0.
Oh no, this is x,
Maybe
sorry.
that was almost-
This is x. This is negative infinity. So it'll be 1 over negative 2, 1 over negative 3, 1 over negative 10, 1 over negative 1,000. It's still going to 0 regardless of what happened. Okay, so that's limit as x approach infinity. Now, let's go back to talk about non-removed discontinuity. Like vertical asymptote. How do we find vertical asymptote like this? 2x minus 7 over 3x minus 5. What does a vertical asymptote happen? When's a vertical asymptote? Do you guys remember how to find vertical asymptote?
It's 5/3.
It's a 5/3. Good. Set denominator equal to 0. Set denominator equal to 0. So that's a vertical asymptote. That's how you're going to find vertical asymptote. On the test, I will ask you find vertical asymptote. You're going to take the denominator. You're going to set it equal to 0. X equal to 5/3. And that's a vertical asymptote. Now, my next question is going to be a little bit harder. How do I find a horizontal asymptote? If you're from Craig, you should know it. If you're from Shapiro, he also taught it. So how do I find horizontal asymptote in this case? If you're from the teacher, not neither of those one, probably you never heard it before.
Is that supposed to be like inverse? Like where you would put like,
No, you were thinking about horizontal
Numerator
line tests, huh?
Set the numerator equal to 0.
No, that would be actually a bad thing to do. Yes.
doesn't it have to do with like the powers or something?
Yes, that has something to do with powers.
Like in the top and the bottom, is it?
Yes, yes.
Is it like 1? I can't remember.
So, okay, so the way to think about it is look at the compare the degrees of numerator and denominator. If they have the same degree, you're going to take the coefficient of the highest degree, which is in this case 2/3. So that's a horizontal asymptote. But we're going to talk about horizontal asymptote in terms of calculus, so let's talk about that. Horizontal asymptote, and there's a reason why that is in calculus. So in calculus, you're going to say divide the whole equation, divide the whole equation by the highest degree. So the highest degree of the denominator. The highest degree of denominator. And then what you're going to do after that, you're going to do limit x approach to infinity of f of x, and also limit x approach to negative infinity of f of x. Now that's equal to some type of number, L. Then if it's equal to L, which is L could be 2/3, could be 5/1, could be 7/3. In this case, it could be 2/3. It could have a horizontal asymptote. So I'm going to show you how do I do it in this case.
Wait, so this is divide the whole equation?
Yep.
By the highest degree of denominator?
Yeah, I'm going to show you every term though, every term. So I'm going to take this, f of x is equal to 2x minus 7 over 3x minus 5, right? I'm going to say limit x approach infinity of 2x minus 7 over 3x minus 5. Now, I don't really care about this because I'm not able to find it, but if I divide it by just like what we did with question 4, if I times 1 over x here, 1 over x here, right? If I do that, that's still 1, right? Did I break any math? So I'm going to divide this by x. I distribute it. And that's equal to limit x approach to infinity of 2 minus 7 over x, 3 minus 5 over x. Does that make sense? I just simplify. The x and x cancel out, 7x, 5x. But according to what we just learned about infinite limits, what happened limit approach infinity on 2? What happened when limit x approach infinity on 2? It's going to equal to what? Wait, who says that? It is 2. Just like what Tyson says, 2. It's a straight line. It didn't matter how tall this Apple Pencil is. It could be 10 years down the road, it's still going to be the same height. It's always the 6-inch or whatever. So it's always 2. Now what happened to this? Well, 7 over x. When x approaches infinity, what am I going to get? 0. 3 minus 0. So the answer is 2 over 3. Here's the reason why they are 2 over 3. It's not because you just memorize it as a coefficient. You actually do math and let it reach infinity. So the answer is 2 over 3.
Excuse me, if x was 0.
So,
Wait, if x was
that's
0,
another
what
question
question?
about.
Yeah.
When you're doing it, it says the highest degree of the denominator.
No, that's horizontal.
Did I say vertical?
No, this side says vertical. Vertical is set denominator equal to 0. So this is this, and this is horizontal asymptote. And you have to reach infinity.
Yeah. So it says divide the whole equation by the highest degree of the
Denominator.
denominator.
What happens when it's a degree higher?
So you divide.
Oh, wait, then there's an asymptote. It's like a,
What is a degree?
It's the 1 over x.
What is a degree?
2, you have x is squared.
Robert, what are you saying?
By x.
I'm good. I got it.
Got it. Okay, Daniela?
So why do you get 0 from 7 over x and 5 over x?
What is that?
Why do you get 0 from 7 over x and 5 over x?
Because you have one other situation. You have a number and x on the bottom, and when they reach infinity, so the bottom reach infinity, 7 is become insignificant. 7 pieces of sand compared to amount of this room can fill the sand is practically 0. Practically. Not really 0, but they are practically 0. Because no longer consider. Then you're going to say, how about reach negative infinity? Am I going to get 2 different numbers? In this case, no. Because you have 2x over x minus 7 over x, 3x over x, 5 over x. That's still going to be the same thing when the x reach negative infinity of 2 minus 7 over x and 3 minus 5 over x. This part's still going to 0, this part's still going to 0, it's still 2 over 3. In this case, both L are the same. Are you going to get a case where L are different? Absolutely. Sometimes. It may. But in this case, no. Okay? How about this case that you also study in pre-cal? What happens if we have 2x minus 5 over 5x minus 7x squared? Yes, Stone?
What's the difference between infinity and negative infinity? Like, what's
There is no different on answer. It's going to get 2 over 3. It just reached both way, different direction, because this part eventually is still going to give you 0. This part is still going to give you 0, just like this and this. Except the way they approach 0 is different. Just think about 1 over 0.1 and 1 over negative 0.1. So it's still going to go to a 1 over 100 or 1 over negative 100. Or 1 over 1,000 as opposed to negative 1 over 1,000. So it's going to reach 0.01 or negative 0.01. It's still going to 0. It's just different directions. Does that make sense? So what will happen in this case? How do I find the horizontal asymptote? What do I divide it with?
1 over x squared.
1 over x squared. So we're going to multiply by 1 over x squared and reach infinity. So 2x over x squared minus 5 over x squared, 5x over x squared minus 7x squared over x squared. Does that make sense? Am I going too fast? So that's going to be 2 over x minus 5 over x squared over 5 over x minus 7 What happened here? This part is going to be what? 0. What happened this one? 0. It's actually reached a lot faster to 0, but it's still 0. Over 0 minus 7. Well, 0 over negative 7, the answer is 0. Now, you also learned in pre-calc or algebra 2, when the bottom degree is higher, usually my horizontal asymptote is 0. And here's the reason why. Because when you reach 0, if you divide by the bottom degree, all the top part is going to go to 0. If all the top part going to 0, the whole thing is going to 0, as opposed to not going to 0. As opposed to going to some other number. Now, your next question is probably going to ask me is, what if the top degree is higher? Right? So let's try it. What if the top degree is higher? If you have 2x squared minus x over 3x minus 4, like this.
Wouldn't it look linear and not have a horizontal asymptote?
Well, this won't look like horizontal asymptote because if you approach infinity, that's going to be 2x squared over x minus x over x. 3x over x minus 4 over x when limit x approach to infinity. So that's equal to 2x minus 1 over 3 minus 4 over
Why
x.
is x instead of x squared?
Because it's in the denominator, you don't look at the powers in the numerator.
So now it's going to be, this part is going to be 0, right? 3 minus 0. Does that make sense?
That was a good question.
Now, what happens if I have 2 times infinity minus 1? Well, can I say that's 2 infinity over 3? Because minus 1 is not comparable to infinity. But, well, just infinity over 3. But infinity over 3 is still infinity. That's a weird thing about infinity. It didn't matter how many times you divide. You can divide it by 10,000, it's still infinity. Square root of infinity still end up being infinity. That's a hard concept to grasp, but that's true. Because the infinity just keep on expanding. Didn't matter if you divide it by 3. That doesn't matter. Yes?
This is just out of curiosity. Like, let's say you have negative infinity and you square negative infinity, do you get positive infinity?
Yes. If you have a negative infinity, you square. Actually, I don't know.
So,
Yeah, I will say yes for now, but there is some situation they are actually interesting. So we will get to that when we get there. But as right now, just assume that's yes right now. But there are, I hate to tell a student a definite answer. It's not because it's bad. It's because there was some situation happen. It doesn't weird. So even like Euler, the famous mathematician, Euler's number. Euler's Leonardo Euler, he even thought -1 is greater than -1 is greater than infinity, which just doesn't make sense. But he worked it out, everything. He figured out that -1 is greater than infinity, and he said that doesn't make sense. So even though the rule still is constantly evolving as the time goes through, a human getting smarter and evolving to better things, there are also other things can happen as well. But I really think about, yeah, if it's negative times negative, it's going to be positive. And that's just the way it is. But there are sometimes the stuff I don't know. So I won't want to comment on that. Because I'd rather comment something I know for sure. Yes, Daniela?
So what happened to the -1?
What happened to this -1? Because you got infinity, right? You got infinity -1, it didn't matter. It's like you go to $1 billion, you go to Bill Gates and it says, can I borrow a bill? Bill, can I borrow a bill? Get it? So, that was such a stupid laugh. So if I go to Bill Gates is going to be like $1 doesn't bother me, so it doesn't matter. Except there's 2 Bill Gates here.
So why wouldn't it be infinity over 3?
Yeah, it'll be infinity over 3. And infinity over 3 is still infinity, and therefore, in this case, there is no horizontal asymptote. Why there's no horizontal asymptote? Because the graph is going to go to infinite. There is no plateau into a number. So there's no plateau into a number, there's no horizontal asymptote in this case. So in this case, there's no horizontal asymptote. So you can have couple cases, you can have horizontal asymptote at 0 or a number or no horizontal asymptote. So yes, Stone.
So if it's a constant next to the x, then it's an infinity? Is that what?
Yeah, if it's on numerator.
Okay.
If it's on numerator. Because the bottom is not changing. The bottom is 3. So infinity divided by 3 is still infinity. Can I sum up to say this is infinity? Yeah. It didn't matter. Infinity times 2/3 is still infinity. So you get 3 situations. One situation is they go to a number, and one situation is go to 0, and one situation is go to infinity. If it goes to infinity, there is no asymptote at all. Got it? Okay. Now we're going to show you the case where you get 2 asymptotes. So this is a case where you have 2 asymptotes. Horizontal. So that case is going to look like this. F of x equal to x minus 3x minus 1 over square root of 2x squared minus 4. So what's the highest degree on denominator in this case? You have to be cautious with this one. What is highest degree?
X? Yeah, like 1.
Why x? Why not x squared? You see that x squared there? Why not x squared? Yeah, square root x squared is equal to x, right? So therefore, you're going to divide it by x instead of 2x. And instead of x infinity, this one is going to be, I'm just rewrite everything. I'm going to divide it by x. But if I divide it by x here, now if inside the square root, I'm divided by square root x squared. And that's equal to 3 minus 1 over x over 2 minus 4 over x squared. Does that make sense? Then when x approaches infinity, this one's going to be 3 over square root 2. Do I need to rationalize? Well, I don't have time to rationalize. So what happens if we reach negative infinity? So I use a different color to show you. So it's going to be 3x minus 1 over square root of 2x squared minus 4. I'm going to divide it by x. I'm divided by x. However, negative square root x, you got to be careful. Because square root x squared is equal to absolute value x. So x is going to be negative on the left-hand side. So it'll be negative square root x squared. So limit x approaching negative infinity, in this case, is going to be 3 over 1 over x. And it's going to be negative 2x squared over x squared minus 4 over x squared. So that is going to be 3 minus 0 over negative square root 2. So you have 2 horizontal asymptotes. Now tomorrow I'm going to show you, sometimes you can have 2 horizontal asymptotes has 2 different numbers. So today is one of the example that's going to get there. Yes, I think so. We're going to see.
It feels like a Monday.
What?
You have homework tonight?
Yep.
No way.
No, today's homework is relatively easy.
One day we'll look back on this day and it will be Monday. Yeah, I'm already looking back at these days, right? Wow. In all seriousness though, like school should be like 4 days a week. Because I know you can't split it evenly down the middle. It's like, at least give us more time to do homework. Thank you.
Because the bottom part, this is just gonna go this one. And the square root is still there, so square root 2. Because that's going to the 0.